Welcome to the Deep Dive. Today we're digging into something, well, something that feels almost invisible. It's about teamwork, but way beyond just skills or communication. We're talking about your internal clock.
We're getting into temporal displacement theory, or TDT, and the core idea is, kind of wild. It suggests that great cooperation might just boil down to whether your internal metronome is ticking in time with your partners.
Exactly. So our mission today is to unpack the protocol they've designed to actually measure this alignment. How perfectly do people's internal clocks sync up when they work together?
Right, and it all comes down to one central metric they've developed, the interpersonal synchronicity index, or sigma sync.
Sigma sync. So that's the score. It's a scale, right? From 0 to 1.
Yep. 0 is total chaos, and 1 is perfect, seamless synchronicity. The whole hypothesis is that when two people manage to align their internal timing, what the paper calls their temporal drift vectors, they hit a high sigma sync.
And that's when you see communication lag just disappear. They get into that shared flow state.
That's the theory. But how do you actually measure something like that? It's invisible.
Yeah, how do you get that score?
Well, to calculate sigma sync, they first have to measure the individual displacement delta.
Okay, what is that in plain English?
It's basically measuring how far an individual's internal clock has drifted from their own ideal timing. Think of it as the tiny, tiny lag in someone's reaction time or their inability to perfectly predict the timing of the next event.
Wow. So are they saying that two incredibly skilled people could still fail a task if they're just temporally misaligned?
Potentially, yeah. And that's exactly why the measurement has to be so robust. It's not just about cognitive numbers.
So what does this setup look like?
They use what's called a time-critical shared task interface. So think of a dual control simulation, like two people trying to fly the same plane.
Where every action one person takes immediately forces the other to adjust.
Instantly. And this setup lets them capture two kinds of data at once: the hard cognitive timing and the physical behavioral synchrony.
So they're not just looking at computer logs, they're actually watching the people.
Oh, absolutely. They're using high-speed video and audio to track all the nonverbal stuff. Is their speech rate matching? Do they pause for the same length of time? Are there small movements in sync?
So they're combining deep cognitive metrics with this observable shared rhythm.
Exactly.
Okay, so let's walk through the experiment itself. It happens in phases, right?
Right. Phase 1 is just getting a baseline. They put two participants together, let them work, and just record the initial success rates and, communication errors while their internal clocks are probably random.
And then comes the interesting part. They actively try to induce synchronicity.
And this is where it gets really fascinating because they try it in two very different ways. The first method is, well, it's pretty dramatic. It's called crisis induction.
They just throw them into a high-pressure situation.
Basically, yeah.
Yeah.
They introduce sudden, high-stakes external pressure that forces them into this tight, coordinated action. It kind of coerces their clocks to align out of necessity.
And the other method is the opposite.
Completely. It's much more subtle. They call it rhythmic cueing.
What does that involve?
It could be a faint shared auditory pulse in the background, or a subtle visual cue, just a quiet, steady beat that's meant to act as an external anchor for their timing.
A sort of metronome for the team.
You got it. And once these conditions are set, they recalculate sigma sync and see what happened.
And the prediction is pretty straightforward, I assume. High alignment scores should correlate with higher success rates.
Higher success, and of course, a negative correlation with communication errors. Fewer mistakes.
Right.
But the final step in the analysis is, for me, the most insightful. It's called displacement mapping.
Okay, what are they mapping?
They're trying to figure out how the synchronicity was achieved. Did one person adapt to the other? Like a novice matching a master's rhythm?
Or did they both sort of spontaneously snap into a new shared rhythm together?
Precisely. Like two swimmers who find a new temporary beat that belongs only to them. And that distinction tells you if that team needs a temporal leader or if it can create its own alignment from the ground up.
So this whole Sigma Sync protocol is really this amazing way of combining hard data with behavioral analysis to map these invisible shared states that seem to define great teamwork.
It is, and it leaves you with a really provocative question.
Like is.
If you can reliably induce these shared temporal states through a crisis or just a subtle rhythm, what does that mean for how we select and train high-performance teams?
You mean for surgical teams or emergency response units?
Anywhere that immediate tight coordination is the difference between success and failure. The alignment of your internal clocks might just be the ultimate hidden metric for success, and that's something for you to ponder the next time you feel that effortless rhythm working alongside someone.